right, this is small chalk talk, lesson 1.1, equations, simple equations. Sorry, so anybody knows that what you would want to do in a basketball game that Mr. Small's playing in is let him go ISO, because he's that good. So this is an illustration of how we're supposed to isolate the variable in any equation we have. Get it by itself, and then let it do its work. I would, well, let me try this again. Because I'm that good, I'd be like, oh, and I would make it, okay? That's why they do that. Usually when I'm playing the basketball, I get isolated, and I just do that myself. So, let me walk through a couple problems. If I have a simple situation where I've got an addition or subtraction, such as this, I would walk through several prompting questions, and I would then solve it. So my first question to myself would be, where's the variable? Well, there it is. Okay, in this case it's positive x, it's on the left side. Then I would ask myself, what is the constant on the same side of the variable? Well, it's a -7. Remember, that sign to the left of the number is married to it, and I use the analogy of the left hand showing the symbol or sign of marriage. So you know that I am married because I have a tattoo, in this case, on my left hand. So what we do is, then we ask yourself, how do you make 0 from that constant? So in this case, to make 0, I would add 7. Okay, that would make 0, essentially canceling that out over there. I do the same thing to the other side in order to maintain the equation's balance. So I add 7 here, and my remaining answer is x is equal to 28. An answer to an equation is called a solution. To check that solution, we plug this back into the original equation. -7 plus 28 equals 21. Use your handy calculator. I don't have one on me, but you use it. 21 equals 21. Oops, there we go. Done. Okay? That is how to solve equations that have positive or negative constants that are basically addition and subtraction. Okay. Now, the process there, and I should have explained this at the beginning, but the process there is to collect constants. So when you're doing addition and subtraction, you're collecting the constants onto the other side where the variable's not. Let me change this around a little bit because we're about to do problems that involve multiplication or division. Process changes, okay? What you need to do is get rid of the coefficients when you've got problems like this. Okay, you're going to get rid of the coefficient. Let me show you an example. If I have a problem, -1/4 x is equal to 7, this is going to be a little bit different. This is a multiplication problem. I know because it's a coefficient variable. So I'm going to ask myself where the variable is. Same first prompting question. Well, there it is. Hello. Okay, hello variable. Variable is always a letter representing an unknown value. Secondly, what I would do is I would say, all right, what is the coefficient with the variable? Or in other words, yeah, what is happening? In this case, we already said this multiplication, and we do have a very easily seen coefficient. It's -1/4. Okay, now I want to ask myself, how do I make 1 out of that? The reason is we want to get x by itself. That's the goal. Isolate the variable. So x needs to be all by itself. No number with it. No constant. No coefficient at all. So we got to make 1 because 1 times x is always x, whatever number it is. So I'm going to either multiply by -4/1. That's called the reciprocal. The reciprocal. Or some students would probably choose, if I'm going to do this, to divide by -1/4, divide by -1/4. In either case, I'm going to get the same answer, which is going to be -28. Okay, what I would do is check this again, do the same check. I would plug this into where x is, so -1/4 times -28. By the way, you know it's a negative solution because the answer over here, the product is 7. So this number and that number have to be negative. I know that that ends up being 7 is equal to 7. Okay, the last little thing to note is that multiplication and division problems can look different. They can look like what I just showed you. They could also look somewhat like this. We'll add That's a division problem. It's a fraction. So in this case, if it's a division problem, I may not know the coefficient there, but I do know that if I multiply by 6, that'll make 1. So I would do that. Okay. You could also see situations where it's as simple as, 3x equals 30. Well, hello. X equals 10. Okay. And that's all for today.
This has been produced and recorded by Mrs. Miller.